Hi everyone, welcome to MathSpellBook. I'm your host Peter, and basically we are going to get back into doing some math and physics today. So I thought I would basically I would probably start off with some physics problems along with some vector problems. I'm basically just going through an exercise that I developed for myself. I haven't been able to do it this morning because I had some prior obligations to do. So I thought I would do it with you guys today. So usually the book I'm using is called Thinking Physics by Epstein. I think that's the name. So basically it's basically a book that asks you like physics questions, and basically you have multiple choice, so you can basically test yourself. So I usually do this I try to do this every morning, but I haven't done it today, so I thought I would do it with you guys today. Alright, and then we'll probably just go into I think the linear algebra questions that Sascha assigned us yesterday. So I'll just open that as well. Bring that over here. Sorry about that, guys. Okay, so let's see what this question is. Okay. Levi Strauss trademark shows two horses trying to pull apart a pair of pants. Suppose Levi had only one horse and attached to the other side of the pants to a fence post. Using only one horse would cut the tension on the pants by 1/2. Not change the tension on the pants at all. Double the tension on the pants. Okay, so that's an interesting physics question. And usually, like with these type of books, hey Jose, how's it going? What's the best part of your day so far, my friend? Okay, so if we imagine the pants on a fence post instead of another horse, well, let's assume that the horse basically pulls this, like, I'm guessing if you have two horses, let's assume that the horses are pulling at an equal amount of force. So if you have a fence post and the fence post has like a force, just chilling on Minecraft. Oh, nice. You know, just basically trying to, I guess, like, catch up with physics and try to like learn more math with you guys on the stream. That's mainly it. Nothing too out there. Okay, so we have A, cut the tension on the pants by 1/2. B, not change the tension on the pants at all. Or C, double the tension on the pants. Yeah. Yeah, physics. Don't worry, it's just basically just basic stuff. We're not getting into any complicated things. I usually do this every morning because I notice I haven't been trying to implement my physics mind that much because I've been just doing like mainly math. So I thought I would just like do like basic like training the physics thinking part of my brain. And I've been like opening up this book to like look at questions every day or every morning at least, and then basically try to answer them. Yesterday I didn't do that well. I think I did 5 questions, but I got a majority of them wrong. I think I only had 1 question correct. And I was like, oh, okay. So that means I have to really think about how to think the world physically. Okay, so if we have one of the genes on a fence post, so maybe we should draw this. So we have a fence post. Oh, well, actually, we can use that. have to draw it by hand. So we have a fence post. And then we have, ooh, that's way too thick. So we have a pair of jeans. I know it's not a very good drawing, but let's go with it. We'll say the jeans, and then we have, it's being pulled by a horse. Yeah, not a very good looking horse. I know. The horse has a little bushy tail. I know it's not to scale, but we'll just so we know that I should study physics and mechanics a little more. There are probably some good parallels with math, but I prefer math, and I need to get used to Scilab. Oh, okay. What is Scilab actually? Is that like a program, or is it a programming language? Okay, so because we know that we know that the force of the pull, the mass of the pull, gravity here, and then we have a normal force up here. Still better than my straw man. And the horse is going that way, and it's applying a force in the vertical direction. So it's the mass of the horse and the acceleration at which it's going. Just draw vectors here for good measure. So in the logo, they have two horses, and I'm guessing they're assuming that both horses pull on the pants at an equal but opposite force. So our choices are cut the tension on the pants by half, not change the tension on the pants at all, or double the tension on the pants. For some reason I'm thinking it's B. Because when you think about it, if these two horses are pulling the pants apart, the pants are staying still in some way. But eventually they will rip. But they're staying still like in where they're, I guess, like they're standing at. So, well, I guess hovering if you think about it. So if we use a fence post, then the pants will just stay by the fence post, which is when the horse pulls. I think that's plausible. Like the tension, not change the tension on the pants at all, because if it is a second horse, then basically like the amount of force they're pulling, it's not going to be like a complete straight line with the lines that are attached to the pants. So when they're pulling, they basically are pulling the pants to a point where it's like the pants are like kind of like about to rip. So I'm gonna say it's B. Oh yeah, it is B. Okay, nice. We got that right. Well, it's like a program to do some numeral calculations and programming language. You can do little programs apparently useful for simulating and automating mathematical algorithms. Oh, okay. That sounds interesting. I never have actually heard of Scilab. I heard of Mathematica, but I've never heard of Scilab. But then again, I haven't been in I guess like the computer side of math and physics, so that's probably the reason why. Okay, so why is the answer B? Suppose one of the horse can exert 1 ton of force, then the other horse must exert 1 ton if the tug-of-war is to be a standoff. Now, if one horse pulls on the post and with 1 ton of force, the post must pull back with 1 ton. Yeah, because it's Newton's third law. Every action has an equal and opposite reaction. At least I hope so. If I'm incorrect in that assumption, like, let me know in the chat. Whether you be on YouTube or whether you be on Twitch. Alright, so for otherwise the horse would pull the pants away, right? So it doesn't matter if the post pulls or if it's so another horse. Is there any force on the pants? No, only tension. Yeah, from this book I actually learned that tension and force are 2 different things. And I guess when you do physics problems you kind of forget that, and it's like, oh, interesting. So the pants actually have tension, they don't really have a force to them. Okay, the underlying idea developed here can be extended. Suppose 2 cars of identical mass traveling at 55 miles per hour, but in the opposite directions, crash and head into each other, or suppose one of the cars drives at 55 miles per hour into an unmovable stone wall. In which case does the car suffer the most damage? There's no difference. The damage is the same in each case. The horse and the car can each exert a certain force. That force can be encountered by an equivalence horse or a car forcing in the opposite direction. Or it can be countered by an unmovable object, and the immovable object in effect acts as a force mirror. It puts out a force that is the mirror image, the reflection of the force that is applied to it. The wall punches you when you punch it, and just as hard. Newton's third law. Oh, nice. We even got Newton's third law right. Okay, cool. So I guess I'm not too bad at physics a bit. I'm not the greatest, but at the same time, at least I'm learning how to apply Newton's laws. Horse and buggy. Okay. This is perhaps the oldest, most famous brain teaser in classic physics, which is correct. Okay. If action always equals reaction, a horse cannot pull a buggy because the action on the horse on the buggy is exactly cancelled by the reaction of the buggy on the horse. The buggy pulls backwards on the horse as hard as the horse pulls forward on the buggy, so it cannot move. The horse pulls forward slightly harder on the buggy, then the buggy pulls backwards on the horse, so they move forward. The horse pulls before the buggy has time to react, so no, I don't think that's right. The horse can pull the buggy forward only if the horse weighs more than the buggy. The force of the buggy is as strong as the force on the horse, but the horse is joined to the earth by its flat hooves, while the buggy is raised and roll on its wheels. I think it's E, because when I think about it, when a horse pulls a buggy, there's friction. So basically, the reason why we're able to walk on the earth is because of like when you walk on the ground, you have like friction underneath your feet. And that's because there's a rough surface, and obviously like the earth is pulling you down as much as you're pulling on the earth, like in theory. And then you basically use the ground to kind of like, you basically use the friction from the ground to actually move forward. So I think it's E, because I don't think it has anything to do with like the equal amount of forces that are like exchanged between the buggy and the horse, because we're still on the earth. So let's check if I'm right. Is it E? Yes, it's E. Nice. We got that right too. Awesome. The answer is E. True, the force on the horse as strong as the force on the buggy, but you are interested in the motion acceleration, not force. A thing's acceleration depends on its mass as well as the force on it. Well, who has the most mass, the horse or the buggy? It doesn't matter because the horse has itself to the earth by its flat hooves. So, in effect, one force pulls on the buggy and the equal and opposite reaction pulls on the horse and the earth. To pull back the horse also requires pulling back the massive earth, while the buggy, being less massive than the earth, moves more easily, but as the buggy moves forward, the whole earth moves slightly backward. If the horse pulls the buggy a foot forward, how far backwards does the earth move? Suppose the buggy weighs 1,000 pounds and the mass of the earth is, I ain't gonna try to read that number, times greater. So the planet moves that much part of a foot backwards, which is hard to notice. Incidentally, you can save some ink by writing. Yeah, I'd rather read it as 10 to the 22 power. Thank you very much. Okay, I think we'll do one more. Okay, popcorn neutrinos. Ooh. I don't know that much about quantum mechanics yet, so like when I see like particle names, I'm like, ooh, what they're gonna talk about in this one. In Mom's frying pan, a kernel of unpopped popcorn decays into a popped popcorn, which shoots off in the direction of P. Okay, therefore, during the decay, it is probable that a subatomic particle such as a neutrino is emitted in the opposite direction of Q. A neutrino is not involved, but some invisible thing is emitting in the direction of Q. Nothing at all is emitted in the direction of Q. Okay. So according to this, the popcorn in the center pops and it goes into P. So P as in the direction P. So it pops and it goes to the left. So the choices are neutrino is not involved, but some invisible thing is emitted in the direction of Q. Not at all is emitted in the direction of Q. Because when I think about it, like, so like if the popcorn basically pops but it goes to the left side, I'm thinking it's because, like, because when popcorn pops, it basically is just like heat, and then when the heat like generates enough energy, it just pops and then creates the popcorn. Now, like it says that it goes to the left side, but I'm also thinking about the vertical directions, such as like oh, hello, the mathematics we want. That's a really good name. I actually like that name. I'm glad that you caught my stream on YouTube. Hopefully the stream looks okay on your end. But I like the name, the mathematics we want. Is it okay if I call you mathematics? How's it going? What's the best part of your day so far? Now, let's see. How can we think about this problem? Because I'm thinking about it in the vertical sense. Because I'm thinking about, like, basically the forces, But the thing of it is that I don't know if the popcorn rolled over there, or did it just pop and then basically just kind of went into the air a little bit and then went to the direction of P. Because technically, the kernel is in the center of the frying pan. I'll do my best to mathematics. I will try to. Let's solve some questions. Yeah, let's solve some questions together. And don't worry, guys. Basically, for me, it's like when I do questions, don't think like you're bothering me by typing up in chat. Unless you're trying to answer the question for me. Like, basically, I like basically collaborating with everybody to, like, you know, this is an interesting problem. It's like, let's all, like, solve it together and stuff. So, that's usually how my streams are. It's, like, basically just, like, research. Well, it's more like a office, like, I guess, like, you can say, you can think of it as, like, we're, like, office workers, or, you know, we're, like, basically in office hours and we're just chatting with each other on how to solve a problem. Like, actual, like, academics do. Solve the INMO 2025 paper. I bet you will love it. What is that? I don't think I've ever... I don't know what the INMO 2025 paper is. Is that like a long list of problems? Okay, so let's think about this. So let's see. Okay, so a subatomic particle such as a neutrino is emitted in the opposite direction of Q. A neutrino is not involved, but some invisible thing is emitted in the direction of Q. Mathematics paper. Huh. I mean, what are the prerequisites for that paper? Sorry if it sounds like I'm, like, if it sounds like there's something in my mouth. It's a cough drop. I usually take cough drops whenever I stream. Because sometimes when I talk to you guys, it's, I need like a cough drop to soothe my throat sometimes. Only 6 questions. Okay. Like, what are the mathematical prerequisites of that paper? Because I think that, like, the amount of math I know is, like, very scattered. Like, I know, like, a little bit of calculus. I know a little bit of linear algebra and stuff. Basic high school mathematics. Oh, okay. Actually, mathematics, like, are you, like, an undergrad student? Are you, like, a graduate student? Math? Are you just like math? Or you work with math? Like, what is your story with math? If you would like to share. But really good. Oh, okay, okay. Let me see if I can Google it. Let's see. Oh, these have the answers on them. Oh, these are the solutions. Interesting. I'm a high school student and I love doing awesome... I'm guessing awesome mathematics. Is that... Oh, that's good. That's good. Well, you come to the right place. If anyone in the chat loves math and physics, or you just want a study stream to keep you preoccupied while you're doing your own projects on the computer, you know, on YouTube, you know, hit the sub button. In addition to, like, you know, hit a like, and maybe if you're watching, if you catch this after the live stream is aired, you know, hit the, like, you know, leave a comment down below. And you can also join our Discord server. That's also in the description down below. And on Twitch, if you're basically watching this on Twitch and you like math, physics, or you just want to study stream to keep up with your day and keep up with your projects, you know, consider dropping a follow as well. Okay. Now, I feel like it might be B, but then I'm also thinking about, because since popcorn pops, it has to go up as well as in a direction, so I feel like it could be either B or C, because I think the reason why it ends up going in the left side, the popcorn, is that when it pops, I think like the vertical, the normal force, as well as like, you know, the force of gravity is like kind of like, but then again, no, I don't think that would work. So basically, yeah, mathematics is great that you're so passionate about math. That's good. That's good. I love the passion. I love the passion. That's what motivates me to do like math problems as well. B or C? I feel like it's either B or C. So when the popcorn pops, when it goes to the left, there's also an equal and opposite reaction. So what gives to the right? Because if it pops and it goes to the left side, I mean, I don't even know if this frying pan has like, maybe it's energy? Maybe it could be the energy of the heat that goes on the right side, which causes the popcorn to like basically like go to the left side. Can we connect sometime? Because I think you would also love awesome problems too. Well, yeah, you can join our Discord server, and basically that's where we can talk about problems and stuff. Although for me, I just like want to learn the basics. I think like when it comes to complex problems, I probably would do well like working with someone else, like talking about the problem is like, oh, I don't know about this angle or that angle. I mean, it's cool when you're able to you know, do certain integrals like by yourself, but at the same time, it's like when you're working on a problem with someone, I think it's like very rewarding, especially if it's a problem that both of you are struggling with. Let me think. I get a feeling it's B, but let's see, nothing at all. Nothing at all is emitted in the direction of Q. Because the heat is coming from the pan, and the heat is creating, is giving the energy the kernel needs to become popcorn. I'm from the US. What about you, mathematics? Where are you from? My gut tells me it's B, but then again, like, there's a little doubt in my mind that it's like C. If we get this wrong, we'll learn something. India? Okay. It's amazing how many people in India love math. I think that's like a big portion of my audience is like from India. Let's see. I think it's B. The answer is B. Okay. Let me see if I can flip this around, because I know the author likes to put it upside down. So let's see. Orientation. Here we go. Rotate to the left. Rotate it to the right again. Oh, whoops, no. Rotate to the left. Then one more rotate to the left. Okay, here we go. The answer is B. If a neutrino came out of the popcorn, they would have discovered it in the 18th century. Okay, but some invisible thing must shoot from the popcorn. What could have propelled it to the direction of P? What is the invisible thing? Steam. Oh, okay, steam. Yeah, I knew it had to be something that was like caused by the heat of the reaction. There is moisture in unpopped kernels, and when heated, it turns into steam, which explodes the kernel. If the steam shoots off in the direction Q, the popcorn recoils in direction P. Okay. I mean, that makes sense. So I guess my intuition was not wrong. But that's good. And we get to learn a little bit more about popcorn. I forget that popcorn has like kernels have like moisture in them. I mean, it makes sense if it's like pops. So, oh, can I change it to its orientation? There we go. Okay, that was pretty good. I think we'll do one more, and then we'll probably move on to do some math. Okay, momentum. Oh, okay, our favorite subject, momentum. Momentum is inertia in motion. And is equal to the product of a body's mass and its velocity. For example, if the speed of a projected cannonball is doubled, then the momentum is doubled. If instead the cannonball's mass is doubled, then the momentum is likewise doubled. Suppose, however, that the cannonball's mass is somehow doubled and its velocity is also doubled. Then its momentum. Well, if they're both doubled, then basically like the momentum would be 4 times. Because I remember the equation of like the simple equation of momentum, which is like mass times velocity. Let's see, doubles, quadruples, ooh. Well, I think it's gonna quadruple because it's basically gonna be like 2 times 2, and then you got the mass and the velocity. However, like I don't know if this is gonna be one of those trick questions where it's like, oh, you're wrong. It's like double because of this and this and this. Like you gotta remember like your deep essence of momentum, you know. But let's see if it's but I think it's C. Let's see if I'm wrong here. Yep, it's C. Okay. To the left. To the left. Okay, the answer is C, which follows from the definition of momentum. The mass x times velocity. Double the mass times the double the velocity equals 4 times the momentum. A body receives momentum by the application of an impulse, which is a force, multiplied by the time during which the force acts. Okay, so we get to learn a little bit something about impulse. Actually, impulse I haven't really touched upon that much. I always I forgot it actually had a name. Let's see. So we can say impulse is the change of momentum. Okay. I think this also involves with like what do you call it? Like it reminds me of the work energy theorem. I guess it's like one of those things that like sometimes you have to like put into your mind, but I think doing this actually makes it a little bit easier for me to remember what impulse is. Let's see, Ft is equal to the delta to m. Okay, so it basically the change of momentum. Okay, so that's good to know. I have to remember that the next time. Okay, So we'll rotate back to the right. And I think we can move on to doing some math now. I think we can erase this. Okay, so I think we're gonna have to I didn't know that was the title of the paper that Sascha sent me. Let's see. Because Sascha did assign us some problems from here. So let us do this. Where's the page? I think it was page, let me look at the Discord. If you guys want to actually do these problems with me, I posted it in the assignments from streams channel in the Discord server if you want to actually follow along with me. So it's page 115 and 116. Okay, 115 here. 2.3. Oh, I think it's before this one. Okay, I think we're gonna copy this. And paste it in here. Yes, allow please. Let me just make sure that you guys can see that. Okay, cool. Alright, let's expand this. Alright. So now we gotta actually use our skills in what Sascha taught us yesterday. So I also want to bring up another book because I felt like I didn't learn that much about using the eigenvalues and eigenvectors to solve matrices at a higher power. So I think we're gonna look into one of the books I love to look at. Linear transformations. Here we go. So obviously we're not gonna do it that way because that would be too much. Okay, so here we go. Even the author says that's a horrible matrix multiplication. Now imagine how many times we need to multiply. Oh yeah, that would be horrible. The best way to see what a matrix does, look inside. Understand that matrix A. You must find its eigenvectors and its eigenvalues. The eigenvectors of a matrix is the natural basis for describing. Okay. Decomposition is the change of basis operations. Okay. A with respect to the eigenbasis. Okay. So let's see. You multiply the matrices Q and the inverse of Q inverse. Alright, so note that the middle matrix lambda has entries only in the diagonal. The diagonal matrix is sandwiched between. Okay. So we have to figure out how to get Q and how to, like, once we get Q, then we can get the inverse, and then, alright, so let's see. And then you do the power onto lambda. Okay, so how do you get Q? Like, that's the one thing I have to figure out. Okay, so lambda. Yeah, this is the typical formula for, like, the eigenvalues. So maybe we should start writing those first. So for the matrix MV, to have lambda and then v here. So we have to figure out what this is. And like the equation that we usually get, if we do this, is this equals 0, then, oh yeah, we also have to do the identity matrix. I forgot about that. Lucky I remembered. So, but we also have to turn this into the identity matrix, and then minus, and then we can factor out the vector, and then we have, okay, so that's how we get the eigenvalues. So I think probably we have to solve for the eigenvalues first, which is lambda here. So in this case we have a, which is 4, then minus lambda, and then we will have 4 minus lambda, and then, oops, no, what am I doing? Should be 3 here, and then 1 here, and then 2 minus lambda here. And then we have to take the, you have to take the determinant of it. Squared 6, and then that plus 5. So we get minus 5 minus 1. So the eigenvalues are, oops, 5 and 1. Okay, so now we gotta have to do this expression. So which is equal to 0. So now we gotta do our matrix again. So let's do 5 because that one seems like equals 0. So then we're left with 1, then 3, then 1 again, and then minus 3 equals. So if we think about this like from a vector point of view, I think we can write this as a, and we also remember that there's a vector here that we can use. So vector AB. We'll just rewrite it down here. Oops. Getting way too ahead of myself there. Okay, and we'll just write this like as a set of equations here. And then minus b 0. So then we're left with A is equal to 0. Oh boy. Because if that is the case, then yeah, then B is also equal to 0. Oh dang, then they're linearly independent. So that means we have vector 0, 0 as an eigenvector. Well, that's for... Oh yeah, that's right. So that one's for 5. Okay, so let's see what it is for 1. So I almost forgot that. I kind of like psyched myself out. So that one's for 5. So, actually I should write it right here. So we'll just square that. Keep that in mind. And let's do 1, 2, 3. And then it's just gonna be this. So total, we're left with 3, 3, then 1, 1 down here. Ooh. That that's not going to get us anywhere. I mean, I want to make sure that I'm doing the math right. It's minus 1, 1, and then 2 minutes. Yeah, that's oh. Because if we put -3 on, like, we're gonna lose out all of them, if that's the case. Did this right. Oh, I think we did the math wrong here somewhere. Yeah, I think we did the math wrong somewhere. Because I see a mistake I did. So, yeah, so 4 minus 3. Okay, so let's do this over. So it's supposed to be this. Oh. That makes it... This makes it just as difficult. So that means it must mean something. I forgot, like, when all the terms... I mean, they're not wrong. It's like, because all the terms go to 0 when this is 0. I mean, they're linear independent then. So we're in a bit of a conundrum here. Because if they're linearly independent, then I don't know if we can do this. I mean, I don't know if that's the right conclusion I can make here. That makes 8, right? I'm trying to do my calculations, so yeah, that would be negative 6, and then this is a bit of a problem. Oh, more math. Hey, Major Finger, how's it going? What's the best part of your day so far, my friend? Would be an amazing hour-long chat I just had. Oh, nice. Hopefully the chat was illuminating and like helped you out with whatever I guess thing you were inquiring about. Brighten my whole mood as much as I can't go to sleep for the next few hours. Oh, okay, that's good. I mean, hopefully you can get to sleep if you need to get to sleep, but I'm glad you're such in a positive mood from that. That's good. That's good. It's always good to actually have those days where, like, you know, you feel like stuff is like, you know, just like away from you. Like, you know, the bad stuff, I mean. But so we're doing the eigenvalue and eigenvector problems that Sascha assigned for us, or at least for me. And I'm trying to do the first one. It feels like everything just fell into place on its own after so long. Yeah. I mean, I love it when those things happen, right? Because, like, sometimes you're, like, questioning yourself on why you do things, and then, like, suddenly it just all falls into place. And then it's just like, wow, I knew what I was working up to, and now this is the result. And it's usually the result you never expected. But I'm glad things worked out for you. I don't need to know the details. As long as you're in that good enough mood, I'm pretty sure it's helping you in your life right now. So it's like, good for you. Good for you. I like to hear when you guys win. When you guys win at life. And it's the wins that you guys feel most satisfied with. That's the best. Nah, I think anybody who is a human being would probably say the same thing. No, but you're the first, so I appreciate you saying that. I will take that as a compliment. Now we're in a bit of a problem here, because it's cool that we got the eigenvalues. The problem is that the eigenvalues kind of lead us into a bit of a problem. Because for that would be -1, and then 3 minus 0, that would be 3. 1 minus 0, that would be 1. 2 minus 5, that would be -3. And if we try to do this as a... Don't just brush it off. people like you are rare. like, I think for me, it's like, I usually think of it as like, you know, I think anyone would probably like be able to like help people get back up, and like, you know, because I believe in raising people up and not putting people down, you know, because like, you know, I know I say I repeat a lot of words, and sometimes I hate it when I repeat phrases. You guys probably know that I repeat basically and you know a lot, and it's like whenever I notice it, I get very flustered. Getting back to what I'm saying though, it's just easy for me to just basically support people. Like, I think supporting people is the best way to like helping yourself like get further ahead in life, because it just feels like you're moving forward without having to put that much effort. At least that's how I feel about it. But of course, there are people that will take advantage of like people that kind of like are not aware of like the dark sides of humanity sometimes. Sometimes I worry about stuff like that, like, you know, encountering the wrong people. And because of my nature, I don't want to like outright like accuse them of like doing something wrong, or like not living life the way I would live, you know? Because that's not how I vibe. Because I think like what's right for someone else might not be right for me, and vice versa. If that makes any sense. Yeah, I don't know what to do at this point. Actually, like, I gotta look back on it. So for computation, what happens if like you just get 0 on both sides? Because they say in this book, geometric interpretation. I know they showed it here, like with a picture. Unless it was in the second chapter. What text are you using? I'm using No Bullshit Guide to Linear Algebra, but I'm also using what Sascha gave us. Apparently the title of this book is Linear Algebra Done Wrong, which I find very funny, because there's a book actually called Linear Algebra Done Right. Where is it? I know there is like a visual I can use that shows me like what happens when like all things are 0. Linearity. No. This is just the overview of linear algebra. Because I remember in my linear, I have a copy of this book too in my library, but I don't know if this copy has the page I'm thinking of. Okay, here we go. One solution if 2 lines intersect. Infinitely many solutions if the lines are superimposed. No solution if the 2 lines are parallel and never intersect. Okay. I guess they don't have a picture, because I remember in my edition they had a picture in it. Let's see. Let's see, one solution, not parallel, infinitely many solutions. Yeah, the weird thing about this problem is that it's correct because both sides are equal to 0 when we think about it, when we write it as a standard of equations. So does that mean that the whole entire basis vector is just 0, 0? I guess that's the only thing I can think of at this point. So the basis vectors are like just 0, 0? Because then A and B have to be 0 at that point. But of course, the thing of it is that now we got to figure out so now I got to figure out how to get this one. Because how do we get Q? How do we get Q and lambda? Oh, maybe for lambda we where is it? Well, maybe we have to do it through here. So maybe let's see, that would be -1, 3. -5, that would be -3. And I think we also have one where it's like 3 and 3, and then 1, and then 1. Such a difficult time here. Let's see, how do they do this? Because I think at this point, I feel like I'm doing it right. The thing of it is that I don't know what conclusion we can come to with this. I'm guessing this doesn't have solutions at the back, right? Got here. Yeah, it doesn't have solutions. Because I'm not getting what this means. Like if we... Because we don't have eigenvectors. We have eigenvalues, but we don't have eigenvectors. Oh, whoops. this right? Yeah, I think so. Because both of these, they will result in like basically just getting 0 equals 0 on both sides, which means that maybe because the thing of it is that the eigenvector can be like pretty much anything at this point. We'll skip that one for now because for some reason I'm just like super confused, like how to interpret that answer. Because I'm pretty sure there's a way to solve it. Because why would they give you like the? Because we're supposed to like find this matrices at this amount of like this amount of power, but I just don't know how to interpret this. Alright, so we have 2.5. Oops. Oh no, not that one. This one. I'll just pull this over here. Okay, we'll copy that, paste that in here. All right, let's see. Diagonalize the following matrices if possible. Determinant of that is +2. hopefully this will give us the right one we're looking for. So now, this, we'll just put AB, then B equals 0, and then So I think for the lower one, this one's for equals 3. So multiply. Oh, that doesn't work either. What the heck? Oh, hello, Woodcraft. You are getting 0 equals 0 since that is what it means for lambda to be an eigenvalue. Okay, am I missing something though? Like, because I know I'm supposed to get the eigenvectors. Is there something that is there a step I'm missing to do the eigenvectors? Because I realize that everything is like crossing out. Do I have to actually like make up numbers? Well, not make up numbers, but like take a guess. Like make a guess on something. Because I think I know how to get the eigenvalues, I just don't know how to get the eigenvectors. Once you have the eigenvector lambda, you should be finding the basis for the kernel of a lambda. Yeah, yeah, it's like, what am I missing though? Because I know I have to do, like this combination with vector v, which allows us to get to this, and then we can basically like try to get a and b. But then I noticed that with every one I did, I'm just getting 0 equals 0 on both sides, and I feel like I'm not getting the right kernel. Like, I mean the stuff in the null space. Let me see if you guys can see it when I zoom out. I don't know if it's too tiny. Might be too tiny. Because the first one we got was this one. I'll zoom in just a little bit. So we did this correctly, I know that for sure. So we got the eigenvalues, oops, thought I had my... So we got the eigenvalues for those. Now the problem is that whenever I try to do this step, I know that I have to basically try to get the variables to give me something else. Like, I know I have to get the variables to give me numbers, but apparently they all cross out with each other. So looking at Ames, you can write it as So the eigenvectors are okay, so the eigenvectors for this one are just this, at least for like lambda 5, right? Is that what you're saying? Woodcraft? Because I'm trying to better understand exactly what you're trying to explain. Oh, okay. No, it's okay. It's okay. It happens. So A is equal to... Oh, yeah, I didn't see that. So then we have A plus B and then B. Meaning that we have to solve for B. So you can choose B to be anything. For example, B equals to 1 and then A. Okay. So is this the point where we actually just have to, we just guess something? We just basically guess a number at this point? Or make it easy? Like basically say guess it's 1 or something? So let's say if B is equal to 1, then basically we would have the vector yeah, since B is free, it can't be anything, but it depends on B. Oh, okay. Gotcha. Okay. Okay. That makes sense. Okay, because I was like, do I have to guess something? Because all these terms cross out, and I'm like, there's got to be another way to figure this out. Okay, so we got this one. So if we do what... So that means basically we would have to say that A is equal to negative B. And if we guess basically B is 1, so then we were left with... Okay. Interesting. Sometimes I understand why people make guesses, but at the same time I'm like, huh. But then again, it's 1, so 1 is like I guess like an easy number to guess from that. Okay. Because usually for me, whenever I do math, I think there's some sort of standard approach. But then again, guessing numbers, I guess guessing easy numbers is probably not a bad thing. Okay, so I think these are going to be Q for... So the first eigenvalue is this, and the second eigenvalue is this. Yeah, technically you can let B... Oh, okay. But why make it complicated? Right. Okay, so now I think we're gonna have to get the inverse of this, because I think this is supposed to represent our Q4, because we want to get the matrix A to some power Q lambda n Q inverse. So I think the Q's are basically the eigenvectors. Now I gotta figure out how to get lambda. So for lambda, because I know lambda is supposed to be a diagonal matrix, or like a diagonal version, like something like this. The one thing is that I have to figure out what those numbers are. but I don't know if it's involving this or something else. Let's see what it says in the book here. Okay, so in decreasing order, so we got the eigenvectors. So yeah, I was correct. So Q is basically all the eigenvectors together. Now, oh, okay. So here we go. Does it matter which eigenvalues are in a row? Does it matter what the order is, or it doesn't matter? I guess it doesn't matter, right? Okay, so now we gotta actually turn this into... So for lambda, we have... we'll put 5 on top and 1 on the bottom. I think that's the best way to do that. I think the order has to be the same order as the eigenvectors. Oh, okay. How do you determine the order of this? Because we got lambda 5 and lambda equals to 1. So which one would be first and which one would be second? How do you determine that? Since you wrote the eigenvector lambda 5 as the first column of the matrix, oh, okay. Alright, so I'm just gonna use my calculator to get the inverse because whenever it comes to stuff like this, I get very lazy. So, because I don't feel like doing the basic operations here. Alright, so matrix, and then then do the inverse. Actually, I would like them in fractional form, please. Okay, so it's yeah, doing it without a calculator gets very tedious. That's the reason why I'm doing it that way. Okay. Now, what power are we doing this to? What power are we doing this to? 2004. Oh my goodness. 2004. What was it? I was starting my freshman year of high school during that time. Wow. Time flies, right? Time flies. But thank you, Woodscraft, for the help. Sometimes I need a little bit of a guide to like show me the way. Okay, so now I'm just gonna do all this. So a to the 2004 power. Oh, we're almost the same age. Oh, okay. That's reassuring. So I think we're gonna have to make another matrix in the calculator. So I will go into matrix, go to the second one, 2 by 2, then 5, 0, 0, 1. Okay, quit, and then we'll do matrix A times matrix B to the 2004 power. And then we'll take matrix A. Oops, I probably should just do this. And then hit enter. Oops. Okay, it didn't come out right, so guess we'll do this. Okay, it's giving me an error on my calculator. Maybe I'm not doing it right. I mean, oops. Every time we hit one stumbling block, we hit another. Alright, let's see what we have to do here. So, then compute, this is the inverse. And then together, the matrix forms the eigen decomposition. Let's see, define the diagonalization of A. Move us on the other side. Wait, more specifically, okay. Yeah, so the way we do this is like this, right? So I don't understand why we can't do this. Like, is my calculator too, like, inferior to handle this calculation? Maybe we have to do it like in a certain order. Or maybe we have to do it like because maybe what's throwing off is the exponent. It might be that. Oh, I guess like I guess it can't handle that. Yeah. It's too big for your calculator. Yeah, I'm guessing that's what it is. Do I have to use an online calculator to calculate it? I mean, we do have the technique. It's just basically just doing the calculation. Is that like the time we basically say let the computers handle it? I think you will have to leave like that. Yeah. Pretty much, yeah. I guess we have to leave it like this, so I guess this is the answer. So we'll just write I guess we'll just write, we'll just leave it like that. Not the answer we probably would like to simplify to, but I guess it's like the time where you're like, we'll let the computers handle that. We'll let the computers handle that. we don't need to handle that, right? Don't do that on a test. But hopefully your teachers won't be that mean and just give you something that's too big for your calculator. Okay, so since we got an idea thanks to Woodcraft, what we need to do. Now we can actually focus on what is needed to be done. So we can say that A is 2 times B. So that way we have 2 times B and then B. And then we can make up a number. So we'll just say B is equal to 1, and then we'll just get like that. And then we also have lambda, which is 2. Well, that didn't look like a good lambda at all. Lambda equals 2. So at this point, we'll be getting 2 minus 2, 1, and then minus 1 here. So then we'll have 2a plus, oh no, minus 2b equals 0. Minus b equals 0. So technically we will have a equals b, which means that if b is equal to 1, then a is also equal to 1. So that way we'll have, oh wait, diagonalize the following matrices if possible. Okay. So we did extra work for no reason. We just got like vectors. So I guess we'll just do this. And I guess that's our capital lambda. Guess we'll go with that. So that was A. And now for B. B is, what is the matrix of this one? -1, -1, and then what are the other two numbers? 6 and 4. Oops. 6 and 4. All right. So we have minus lambda 0, 0 lambda equals 0. Then minus lambda minus 1, 6, 4 minus lambda equals 0. Hey Sascha, how was your stream? How was the big chat with hyper Keller manifolds? So now I'm just writing every step so I don't forget. So this had a letter on it? No. So we'll just put it as M. So M lambda is equal to, then minus 6 times -1, which is positive 6. Then we'll have -4. -4 lambda, then plus 1 lambda, then plus lambda squared. So I had to have help from Woodcraft to like solve the first one we did. This first one. I couldn't type it in my calculator, so I just left it like this. That's the thing I don't like when it comes to like math problems that are very that involve a technical a computer. It's like, oh my gosh. I just left it like this. because I couldn't fit it in my calculator, so you know, like I just left it like this. hopefully that's okay. But we're working on the second one now, so I think the reason why I got stuck on this one was because I wasn't getting A and B, so I had to literally so basically according to Woodcraft I had to actually guess one of them, so I just decided to go with what they suggested, guess that B is 1, and then basically just go from there. I didn't know you had to do that, so I was like, oh, okay. So I guess we're gonna have to pull a 1 out of our hats. So lambda squared minus 3 lambda, and then we'll have positive 2. Meaning that we have lambda minus 2 and minus 1. So lambda 2 and lambda 1. If we have to diagonalize it, we'll leave it at that. I think. Guess we'll leave that as like our capital lambda. I mean, hopefully that's right. Because it says diagonalize the following matrices if possible. But I don't know if that's the correct way of interpreting that. If I'm wrong, please tell me I'm wrong. Let's see. What is C? Oh, we have a doozy for this one. So instead of going back and forth, I'll just copy it and paste it down here. That's fine? Okay, cool. This one I'm not going to enjoy doing. Because it's like a 3x3. So... Oops. Hey Grandma Ursula, how are you doing? What's the best part of your day so far? Now... Okay. Had a long power outage today. Oh, I'm sorry to hear that. So I had to actually do stuff like do stuff that was not on my computer. Oh, that was nice. Oh, okay. So you actually like had a relaxing day around away from technology. That's fine. Now we gotta do the determinants. Oh my goodness. Okay. once you feel comfortable with those computations, I'll show you how to use symbolic algebra systems to make those computations for you. What's that? Symbolic algebra system. Is that like a computer program, or is that like just like a math trick? Like a computer program that can do the exact computation for math. Oh, okay. I see. Yeah, I'm not gonna like this. Hopefully I wrote the determinants right. No approximation. Okay. This weekend I had to compute a rank 48 by 48 matrices. I used one of those systems to carry the computation. Oh, I don't blame you. That sounds like a nightmare. is definitely monotonous. Okay, I like grouping sometimes. Problem is that this one let me see if I did the calculation right. You never know when you miss something. Positive A. The degree 3 and the degree 3 and degree 2 terms are fine. Okay. I'm trying to make sure. It doesn't hurt to make sure. Been up to these past weeks? Basically just doing like simple linear algebra problems mainly. Yeah, I knew I was going to make a mistake somewhere. Let's see. Welcome back. I knew I was gonna make an arithmetic mistake somewhere. Negative 30 plus 10. Negative 21. Okay, so I must have made a mistake somewhere, because let's see, 23, 90. Oh, okay. Oh, no. 23 plus 10 minus 30. Where did I screw up though? Let me see. Maybe it's this part. Let's see. That is the way that result is correct. Negative 2, 20, positive 6, yeah, that's correct. So this one's times 2, negative 30 plus 10, 90, yeah. I want to double check. 15 times 6, yeah, that's 90. I think you should use the polynomial I gave you and move on. There are so many silly mistakes while doing those computations. I recently had a research idea that could be promising, that could use I could use for my PhD thesis, but I know nothing about the topic. I don't know if it's silly or not. I don't think so, because if you don't know anything about it, that means there's a lot to learn to it. So I think you should just go for it if you feel passionate about it. Okay, so according to Sascha, more likely I did the arithmetic wrong. So I'll go with what he suggested. Yeah, this is the reason why I think a lot of people don't like math, is because whenever they have a long math problem to do, and it's like long and arduous, that's when they're like, oh my gosh, why did they give me such a long problem to do? And I get why they probably do it. It's like, oh, it's to get your math muscles going and stuff. But at the same time, it's like, you don't want to go overboard. According to the computer, okay. Okay, so 21 and 18. Yeah, they're separated by 3, by a factor of 3. So we can separate this. Oh, let's do that actually. Actually, bring out a negative 3. So that way we have a positive 7 and a negative 6. Oops. Made a mistake there. Should be a negative 8. let's see. I mean, that's what I thought. There is barely any research about this exact topic. I don't know how to start tackling it, and that makes me believe it's either A, a good idea to look into, or B, I'm stupid and I won't be fruitful for everyone to accept. Well, I mean, it depends on how you feel about it, though. Because, like, I mean, what's the topic? Do you know what the topic is? For me, I think anyone that is willing to go into the unknown is, like, pretty brave. I don't think you did the factorization right. Knowing me, I probably did not do the factorization right. I know that for a fact. Oops. Here the author gave you a root. Is one of the eigenvalues. So you can apply the division algorithm to reduce the polynomial to a degree polynomial. Do I have to? It's like, do I really have to? Fine. More like a childish antic. I'm like, do I really have to? Let's see. Okay. Yeah, actually like Grandma Ursula, like the thing of it is that like what is the topic you want to look into? And if it's in theoretical physics, I'm curious about it. I'm curious what that is. Because this one's minus, yeah, it has to be minus, and then oh. didn't make an error. I think I might have made an error. Minus, and then that'd be negative, but then do I have to make it negative? I want to generate a category of formal systems that is capable of representing physical reality with constraints like they need to converge, concepts like Lorentz invariance or gauge invariance. Ooh, study morphisms between. So is it like a formalism like you would probably see in mathematics, like with axioms, but only for like towards physics and like physical like theoretical systems? That sounds interesting, actually. Yeah, that's what I was thinking too, actually. Like, did I do a sign mistake? I feel like I did a sign mistake somewhere. Because the one thing is that if you multiply this by -9, because this is considered like a subtraction problem. See, we did the last time, so we had a positive. Yeah, I think we did it the last time, so I think that's what we're supposed to do. Like so. And then this would be positive 18, and then we would minus that. Oh, actually, I would be very interested in how you research that, actually, because I remember watching a video. I forgot his name. Let me see if I can, because I sent Sascha the same video. It was a video by Gabriele Carcassi. I think he's a mathematical physicist. Like, he was talking about we need physical mathematics. We need like actual mathematics that represents like physical reality in some way. So I think that would be a pretty interesting like how you would do it. It started with, actually that's the reason why I started the channel, actually. Grandma Ursula, I mean, you know more about math and physics than me, so you know, like, I would like to learn up to the point where you're at, so that way I can actually incur on the same, like if I was doing a PhD, I would probably do the same thing too. Try to make a formalism out of it. Probably look different to ours, and they use the same axioms, right? There are many ways to write the. I'm always confused when someone else does it. Yeah, true that. But would need to represent the same reality as ours. So whenever we have different ways to represent the same underlying reality, there's a dualism and probably a morphism between them, right? Maybe finitism. I think it's very interesting. I think you should go for it, because like that's something I want to develop for myself, but I'm not really high in the skill when it comes to like math proofs and mathematical physics. But I'm willing to actually put myself through the ringer to like actually learn a little bit of that. But I think you should go for it, Grandma Ursula. For all those that are on YouTube, if you're not able to like see the Twitch chat, basically Grandma Ursula is like basically telling us an idea they have for their PhD thesis. So I think it's a pretty interesting idea, because that's the thing that I want to do for myself when I'm learning math and physics. Like, if you manage to like create that framework, Grandma Ursula, I would be like, yo, I want to be able to like follow your example, because I think that's very cool. Gotta do my master's thesis there first. Oh, okay. I mean, like, the thing of it is that I heard that with string theory, like, they put, like, I think they put some of their data into an AI, and the AI was able to calculate the exact, the exact mass of a quark, or, I think it was a quark, but it wasn't matching with, the measurements that we had in, like, in our universe. but it could be like one of the measurements of a quark, like within another universe. So, what did you find, Sascha? What did you find? Negative lambda, the mistake. So is it supposed to be +9 or is it supposed to be -9? Oh, okay. Okay, so if it turns out to be like that, then we have this. Then we know what this turns out to be. We did it. We did it. We did it, Reddit. Thank you, Sascha. Thank you for the help. Yeah, usually when it's long and arduous, I don't see like my mistakes that much. Like usually, like I don't mind writing all this stuff because it makes me think of those scenes in the movies where it's like the physicist or the mathematician writing a lot of stuff on the board and they're like looking at it and they're trying to figure out what the problem is or like what the solution is within these equations. I think that's really cool. So at this point, we're not sure if our matrix is diagonal. Is it because it has a multiplicity here? Is that what you mean? Okay. Yeah, because I remember you said that yesterday, like something about multiplicity, and I'm like, okay, maybe that's the reason. Because it has to be one exact eigenvalue, right? Like we have to have like one exact eigenvalue for like each one, right? I mean, at least I'm getting the hang of it, though. The associate null space must be dimension 2 to be diagonalized. Not necessarily. Oh, okay. Hold on. Dimension 2. Now, I think the dimension part I forgot. Like, I forgot that detail. Because I forgot what the dimensions associate, how do you associate the null space with the dimensions? I forgot, wait, hold on. Because I think it's supposed to be, like, you have to take the dimension of the, what is it? I think the set, like, the set or the vector space you're using. So when you look at the null space for M3, is it like 3 minus like 2 or something? Because now I'm thinking of letters, because I know there's like N and M, and you have to minus M and N with R, and I'm trying to remember what that's from. I think it's like for like the transpose, like the transpose column space and the transpose for the row space. In order for M to be diagonal, this null space should have a dimension. I is the identity matrix. M is your initial matrix. Right. Yeah, I'm trying to remember where you get the dimension from. You have to do the computation. Okay. Well, I think that will do it for today, guys. But thank you for joining me today. We did some physics problems, well, physics questions, I should say, and we did like a good handful of like 2 problems. So I'm starting to get my feet wet, like with these eigenvalue problems. I mean, with you guys' help, I managed to like learn a lot more. So like we did 1 question and we did like 3 parts of like 1 question. So I think that's good. How many more do we have to do? Let me check here, because I think the amount we have to do for this one was like we did 1, 2, so we have 2 more. So I think we can do those 2 tomorrow. Thanks for being there and streaming. No problem, no problem. Actually, like Grandma Ursula, like in the Discord, if you're in our Discord, like, you know, like update me on what you're like, because I'm guessing like your PhD thesis idea, like if you come up with like any ideas on it, even though it may seem complex and stuff, like share it with us, because I'm actually very intrigued with it, because that's actually why I started my own started my channel, you know, because I want to be able to develop like, you know, physical mathematics too, and I want to be able to like interpret like the physical world in a mathematical way. So your idea is kind of an inspiration to me, more so, and I actually want to learn from you as well, like, because you probably are already like high up in theoretical physics, and Sascha is like high up in math, so I feel as if like we can learn a lot from each other, because like I'm still struggling with just basic physics alone. You know, so I feel like you have a lot to share. I'm not that high up. Yeah, but you probably already are in the weeds. Like, I mean, what part of theoretical physics are you researching though? Like, before we end stream, I actually want to know. Because the thing that got me into theoretical physics, obviously, I did catch the string theory bug, but I also am interested in knowing about like loop quantum gravity, all the other theories out there, see what they all have in common, and see what things they get wrong and all that stuff. Because like if you're doing your master thesis already, I'm guessing you're probably doing some research on a particular topic that's related to the particular goals you set out for the theoretical, the PhD idea, that thesis idea you have. If that makes any sense. I just want to know what your field of research is for your master thesis currently, because I'm guessing it's related to what inspired you to think of this idea for your PhD thesis. I'm not on my master thesis yet. I'm doing a course on taking things slow. I haven't started my master's yet. Okay. I mean, do you know what field of research you want to get into? Is it related to like mathematical physics, or is it just related to like more of the theoretical side of physics, like things involving like cosmology or something like that? Because I think that would be a very fun project to engage in. I think like the thing, I like philosophy of math. Okay, that's fair. Actually, the thing of it is that with mathematics, like you just have to think of like, I guess, the topics. Because with geometry, you actually have to have a plane, whilst in like number theory, you don't have to. So I think with physics, you have to think about what are the axioms of physics. That's the one thing you have to think about. And does each different field of physics actually has its own axiom system? That's one thing to think about. I want to know what's representable by a formal system. How are we constrained by the language we use? Okay. Yeah, because I think like with mathematics and physics, it's always going to be a bit complicated, because you don't know if the axioms you're using are actually going to fit with the physical world. I think with physicists, they usually look at the math and they see how it behaves, and they try to think about how it behaves in, like, how the physics behaves, and they try to think about what mathematical idea or mathematical branch behaves the same way as this physical system. But then again, you also have to think about, like, how do I turn something physical into something mathematical? Like a system of axioms that we can use. Because I think with classical mechanics, like, the axioms will probably be different than the axioms in quantum mechanics, and vice versa. But, you know, for any of you guys that are watching on YouTube and Twitch, thank you for checking out our stream. So for all those on YouTube, you know, consider hitting the sub button, as well as if you're watching this after the live stream has been aired, so basically drop a comment down below and like, hit the like button. Whatever I can do to improve the stream, or whatever you guys saw I was doing wrong in the problems, you can put it down in the comments down below. Every link will be in the description down below, such as the Discord server, my Twitch channel, as well as my video game channel. For all those that are on Twitch, you know, consider dropping a follow if you like math, physics, as well as study streams to, like, you know, get yourself in a more productive mood. And yeah, I think that will do it for today, guys. We will be back tomorrow, hopefully, because I'm pretty sure I'm gonna be streaming tomorrow. But, you know, I will update you on the Discord server if anything turns up otherwise. But yeah, so always remember, guys, everyone is precious. You guys are just as precious as everyone else, and I will see you guys in the next stream. So take care, guys. Bye-bye.